Hi, everyone. Welcome to your independent work for this Wednesday. Um, it's going to look like this pretty much the same as it has in the past. We're going to take some notes for an upcoming Desmos lesson, and then you're going to work on 3 skills in IXL. The 3 skills in IXL that I've assigned are all about ratios and equivalent ratios, because those are the skills that are going to support what we're doing in Unit 2 of Desmos. So you just took your Unit 1 quiz the other day, and now we're going to move into a new unit. So instead of just being in scale drawings, we're going to be in proportionality. Scale drawings are just one type of proportionality. They are drawings or copies that are proportional to an original, right? There's this idea of proportionality between the drawings. Well, there's lots of other things that could be proportional, right? Like when you're making a recipe and you want to double it or triple it, you have to make sure that the ratios or the amounts of things that you're using stay proportional as you make things bigger. Or when you're traveling at a constant rate, like you're in a car, the amount of distance that you travel is proportional to the time that you've been traveling, right? There's lots of other things in the world that could be proportional to one another. And so we're going to start looking at more types of proportionality. Proportionality is essentially grounded in this idea of equivalent ratios or equivalent fractions. And so that's where we're going to start with the lesson 2 notes. The unit 2 lesson 1 notes. So I'm going to be on page 45 in the book. So we're skipping way forward, right? We're leaving unit 7.1. And now we're going to be up here where it says unit 7.2. So 7 for 7th grade, 0.2 for unit 2, and then lesson 1 paint. So it's page 45 in the book. All right, so let me share my screen and we'll do these notes together, and then you can get to your IXL skills, which I linked to this assignment. Make sure to log in before you click those links, because if you just click the links, it'll take you to the skills and it'll let you practice for a little while, but then it'll say you're out of practice time for the day or whatever. That means you didn't log in. So log in, then go click the links. All right, sharing my screen. There we go. Okay. And maybe a little light. Is that better? Okay. Fix this. All right, that'll work. All right, so the first thing it says are, what are equivalent ratios? 2, well, actually 2 or more, really, I should say. I was going to say 2 ratios, but, well, we'll write 2 ratios, but it could be, you could have any number of equivalent ratios. 2 ratios are equivalent if they represent the same number. When written as fractions, they must be equivalent fractions. And so remember, equivalent fractions are just fractions that are written differently, but when fully simplified, if you like that term, they wind up representing the same number, right? So let's put a couple of equivalents or a couple of examples over here in the My Notes area. So there's like multiple ways you can write ratios, right? One way that people write ratios is with a colon. So like you might have, I don't know, 10 of something to 20 of something else. And then you might, maybe this is like part of a recipe and you make a 10 times big as batch because you're serving a big banquet or something, right? And so that would be equivalent to 100 parts of the first thing or 200 parts of the other thing, right? And to test that these are equivalent, the way I would do it is write them both as fractions, right? The ratio 10 to 20 is the same as the fraction 10/20ths. And then when you're working with equivalent fractions, if you can make one of the fractions look exactly like the other fraction by multiplying by 1, And what I mean by multiplying by 1 is 1 has all these different representations, right? As long as the numerator and denominator of a fraction are the same, it equals 1. So 3 over 3, 4 over 4, a million over a million, these all equal 1. Well, if I can multiply or divide this fraction by 1, meaning the same number on top and same number on bottom, and make it look exactly like this ratio, which would be 100 over 200, then they're equivalent fractions, which means that the ratios are equivalent. Equivalent fractions, equivalent ratios, kind of the same thing. All right, so, well, what if I were to multiply 10 over 20 by 10 over 10, right? Or 10 on top, 10 on bottom is kind of like how I like to think about it. We're not changing the value of the fraction 10/20ths, because 10 over 10 is just 1. And when you multiply something by 1, it just stays itself. And so, well, 10 times 10 is 100. 20 times 10 is 200. And so we got the same ratio as this one up here. So these would be equivalent, right? All right, let's do one other one, just to talk about another way that sometimes we see ratios written. Sometimes you see ratios written with words. You might see like 3, 2, 4, right? Like 3 of this thing to every 4 of that thing. And another word that people like to use is per. So maybe this ratio would be equivalent to like, I don't know, how about 15 of this thing per 20 of that thing, right? Just different ways to write ratios. So you can also write ratios as fractions, which is kind of what we're doing here. All right, well, let's check if these are equivalent real quick. I'll start on this side first, just so we can do it kind of differently. So 15 20ths, right? I'm just writing 15 per 20 as 15 20ths. And then I want to make this look like 3/4. Well, I noticed that if I were to divide 15 by 5 and divide 20 by 5, I would get a 3 over 4. And so I want to divide this by 5 on top and bottom. And I'm showing you a different way to write this. See, up here I wrote times 10 over 10. And here I'm writing divided by 5 on top, divided by 5 on bottom. Both of these are like acceptable ways of writing what we're trying to do here. And so this equals 3/4, which is that other ratio we had. So those are equivalent. All right, and so lots of times we encounter this idea of proportionality or equivalent ratios in tables like this, where we have some amount of one quantity along the first column. Lots of times we like to refer to the stuff in the left column as our x values and the stuff in the right column as our y values. We won't necessarily always look at it that way. In fact, sometimes I might just be the mean math teacher that switches them on purpose just to see if you're paying attention. But if they're not labeled, then we get to choose, right? Like I can make them any letter or variable I want. So left is x, right is y. All right, and so I want to see I want to build equivalent ratios in this one, right? So it's talking about Brielle mixed 8 cups of blue paint with 6 cups of yellow paint. Okay, so 8 blue, 6 yellow. I think that makes some shade of green. Complete the table so that each new mixture will match her original paint color. So if she needs more of this same green color, she has to make sure that she's always using 8 cups of blue and 6 cups of yellow, or at least 8 parts blue, 6 parts yellow, right? So that the color turns out the same. If she uses too much blue or too much yellow, they'll mess it up. All right, so the original ratio we're given is 8:6, right? Or 8:6. Okay, so what I notice here, see how in the fraction here, in order to build my equivalent fraction to go from 15/20 to 3/4, I divided the top number by some number, which in this case was 5. In order to keep things equivalent, I just did the same thing to the bottom. I divided it by 5 as well. As long as you're doing the same thing to both sides, multiplication or division only, then your ratios will stay equivalent. So I look at what's going on here. 8 to 4. In order to get from 8 to 4, I would divide by 2. Okay. Well, that just means like if I'm thinking of it exactly the same as over here, I just need to do the same thing to this side, divide by 2, and I get a 3, and now I know I've got an equivalent ratio. 8:6 is the same thing as 4:3. That's one way to do this. Another way we'll do this is we'll be talking about something called the constant of proportionality. There's this number that connects the left and right columns. It's really exactly the same thing as the scale factor, but just used for things besides scale drawings, for paint and for cookies and for speed and whatever, right? So remember, the scale factor was that number that you would multiply your original drawing by in order to make the size of the scale copy. It's the same idea, but now it's just the number that we're going to multiply the blue cups by in order to get the yellow cups, right? And so I'm looking at what number do I have to multiply 4 by in order to get 3? So like, what fills this blank? 4 times blank equals 3. Just for the sake of time, I'm just going to give you this answer. It's 3/4 or 0.75, whichever one you like. All right, so let's do decimals. I usually do fractions, so we'll do decimals this time. So what that means is that whatever number goes here times 0.75 has to equal 9. Okay, well, that's hard. That's hard to fill in that blank. Does something times 0.75 equals 9? But I can work backwards. That means 9 divided by 0.75 has to get whatever goes in this blank. We could just punch that into a calculator if we wanted to. It's not a big deal. I can do it in my head. I just happen to know that it's 12. But look, it also worked with the other way, right? But honestly, the easier way to do this question probably would have been to say, okay, well, this 3 is being multiplied by 3 in order to make this 9. And so on this side, 4 times 3 makes it 12. But you need to be able to do these tables both ways. You need to be able to use patterns that go down the columns, and you need to be able to multiply and to divide across the columns in order to be successful in everything we're doing. So be aware of both ways to do these questions. All right, and so we weren't given any information for the last one. I think the idea is we're allowed to make up our own equivalent ratio for this one. Okay, well, 4, 8, 12. I think naturally the next thing to do would be 16, right? Okay, 16. But see, that makes it, what makes that kind of hard is like, oh, but how do I go from 12 to 16? Well, I see a couple ways I could do this problem. I could look at the fact that 8 times 2 would make 16. And then so that means that whatever goes in this column should be 6 times 2, right? It's going to be 12. 12 is the answer. But you know what? I want to do it the other way. I want to use this number, this thing here called the constant of proportionality. And I'm going to finish off by going 16 times 0.75. That also equals 12. That's another way we can get this answer. All right, and so this last part here says, will a mixture with 16 cups of blue paint and 14 cups of yellow paint match the original paint color? Explain your thinking. Well, I didn't even realize the next question was going to be about 16. We know how many yellow she's supposed to use if she's using 16 blue, right? We just did it. 16 blue, she should use 12 yellow. So if she does 16 blue and 14 yellow, that green color is going to come out too yellowish, right? It's not going to be right. So we could just say that as our answer, but let's do it a little more mathematically. Let's show the math one more time. We know that the ratio between these two values should be 3/4 or 0.75. That's what this number right here represents. However much blue paint she uses, she should use 3/4 as much yellow or 0.75 as much yellow. And so 16 times, I really should stop using an X for multiplication. You guys got to get used to seeing the dot instead of, because X is like a variable all the time now. So I'm going to change that to a big old dot. 16 times 0.75 equals 12, not 14. So 14 cups would be too much yellow. All right, sorry if that video was a little bit long. Go do your 3 IXL skills. Remember, you're only supposed to work for like 40 minutes on this stuff. I don't know how long this video turned out to be, but I mean, if you spend like 30 minutes on these IXL skills and they're too hard for you, or you can't get it done, or IXL is being weird and telling you your answers are wrong when you know they're right, just send me an email and let me know what's going on. So I'll give you credit. Doesn't have to be the end of the world. All right. I'll see you guys tomorrow or Friday.